Continuing from yesterday, we now deal with the particular, or it can be called unique solution. So if you see the word particular or unique solution, that means we want to find the solution at a specific point. Now, let's have a look at the first one. Let's write it down. So we got 1 plus x to the power 4. That's dy multiplied by dy over dx is equal to x to the power 3 times y, and then we got these values to substitute. Right, so step number 1 is to separate the variables. Get all your your y's on one side, dy on one side, x's and dx on the other side. So what I can do here is I can multiply by dx on both sides here to get rid of this dx. So that will be 1 plus x to the power 4 dy is equal to x cubed times y multiplied by dx. So now I'm keeping dx on the right hand side. So I'm going to divide. I want all the terms with x on one side, all the terms with y on the other side. That's what I'm doing here. So I'm going to divide here by 1 plus x to the power 4. So I will have it on the right hand side. And this is dy on the left hand side. So this y, I need to divide by y so that y comes down there. I'm going to do it one time in one step there. Right. So here's my dy. And I'm dividing by y, so that's dy over y. There's my x cubed dx. I'm dividing by 1 plus x to the power 4. Alright, you got that? Now, once we have separated the variables, so it's clearly separated, now we need to integrate both sides. Right, so on the left hand side, I have 1 over y. I'm integrating with respect to y. On the right hand side, I got x to the power 3, all divided by 1 plus x to the power 4. So, if you've done the examples that we did yesterday, clearly these are fractions where the denominator is a function of x and the numerator, well, in this case, function of y. And the numerator is an exact derivative, f prime on the top. So you can see this satisfies the condition. This also almost. Can you say that? So you know if this is the case, then the answer is always ln absolute value of the denominator plus c. So now, when you integrate 1 over y, so how do you understand this? The derivative of y is 1. So therefore, the answer is going to be ln absolute value of the denominator. You don't have to put down plus c here, you put down plus c on one side. Yeah. Now, I'm going to do this by inspection. You can always redo by use substitution but by now you should be getting used to the inspection, as you see. Then you must, it's good to know both methods instead of just one method. Right. So what is the derivative of 1? 0. You don't have to worry about that. What is the derivative of x to the power 4? It's going to be 4x to the power 3. So what's missing then? 4 is missing in order for it to be f prime. Right. So now k must cancel the 4 there. So that will be 1 over 4 there. You're clear with that? 1 over 4 times 4. You must get back to that previous step, which is a positive 1. Now, k f prime f, you know, 1 time is going to be 1 over 4 ln absolute value of the denominator plus c. Alright, so this is a general solution at this point. You got plus c here, so it's just a general solution. Right, so now we need to find the particular or unique solution when x is equal to 1, y is equal to 2. So at this point, when x is equal to 1, y is equal to 2, we will substitute these values. So now, so I got ln absolute value of y is equal to 1 over 4 ln of 1 plus x to the power 4 plus c. So where I see y, I'm going to replace it with 2. Where I see x, replace it with 1. So now that's a 2 there, and that's a 1 there. So now I need to work out the value of c. So this is going to be ln of 2 minus 1 over 4 ln 2 there. But you can use your calculator one time and get the answer. So therefore c is equal to 4 over 4 minus 1 over 4 is 3 over 4 ln 2. You remember the calculator? You can round up our answer to 3 decimal places. So that's 3 over 4 ln 2. You get 0,52 there. You got that? 0,52. I said round up to 3 decimal places, but this one cannot be rounded up to 3 decimal places because the third decimal place is a 9 and the fourth decimal place is greater than 4. So 9 has to change. You'll understand how to round off. Right, so this is going to be 0,52. So therefore, now the particular solution all you're going to do is go back to the general solution, copy it down, and write down the value of c there. That is the particular solution. So therefore, ln absolute value of y is equal to 1 over 4 ln of 1 plus x to the power 4 plus 0,52. That's all. That is the particular solution. Right, so we integrate. Let me give you 2 minutes to try this one out first. Right, so let's separate these variables. So we got dx, dt now. Right, so let's keep the dx on the left, dt on the right. Right, so now if I cross multiply here, I'm going to have cot squared x dx is equal to t multiplied by 1 plus t squared dt. Right, now we separated it. Let's integrate both sides. So I need to integrate the left hand side with respect to x, integrate the right hand side with respect to t. Now, the right hand side needs to be simplified. The left hand side also needs to be simplified because there is nothing that you can differentiate that will give you cot squared. So this is not a standard integral. If it's not a standard integral, we need to use our square identities to change it into a form that we can integrate. So we are dealing with powers of tan and cot here. You go back to powers of tan and cot to refresh your memory. So, square identity. The square identity 1 plus cot squared is equal to cosec squared. Right, so you make cot squared the subject of the formula, and it's equal to cosec squared minus 1. Right. The right hand side, okay, this, I just said that it's not in standard form. The fact is there's more than one way to deal with this here. You can deal with it as it is using our f prime multiplication, right? Because the derivative of t squared is 2t. Okay, the derivative of t squared is 2t. So I think, let me do it the more difficult way. You're used to, obviously you'll know that t times 1 is t, t times t squared is t to the power 3. That is correct. So you did it that way, and I will show you a different way now. Right, so now that's going to be 1 plus t squared to the power 1 multiplied by t there. So I want to use the standard form that we always use. Alright, so what is the derivative of t squared? It's going to be 2t. So if I write down a 2 there, I'll cancel the 2 by multiplying by 1 over 2. Can you see that? So now, this will be half, and then 1 plus t squared, and this 1 here, 1 plus 1 will be 2 over 2, plus c there, that's the right hand side. So what did I do here? I went k f of x to the power n multiplied by f prime x dx. I'm just using x, you're used to x. This is the standard form we are dealing with, the type multiplication, exact derivative here. So this is equal to k f of x to the power n plus 1 all divided by n plus 1. That's it. 1 plus 1 is 2 over 2 there, you can say that. So now, this becomes 1 over 4 times 1 plus t squared all squared plus c. If you did it the other way, you're still correct. That means you're going to have t, so you integrate, it'll be t squared over 2, and it will be t to the power 4 over 4, after you remove the brackets and simplify them. Right, but let's look at the left-hand side. Now, what did you differentiate that gave you cosec squared? You need to know your differentiation. The derivative of cot is negative cosec squared. But this is not a negative, this is a positive, so when you integrate cosec squared, the answer will be minus cot x. Integrate minus 1, that is minus x. So we're done with that. This is the general solution. Now, what are we looking for? We want the particular solution or unique solution. So now, at what do we have there? X of 1 is equal to 0. What does that mean? This, obviously there's x and there's t there. Right. So now, x of 1, it means x of t. That means when t is equal to 1, it's like f of x. Right. But in this case, it's f of t, or x of t. So when t is equal to 1, so you must be able to understand the information given to you. When t is equal to 1, x is equal to 0. That's what it means. Now, you know that what is it? This is trigonometry. So therefore, calculator in radians. And I can see you're going to get an undefined. This thing is not going to work out of here because of cot. I can just see the problem. Unless the problem is they're supposed to give you it's the other way around. When x is equal to 0, t is equal to 1. Because clearly it's going to, I can just see it's going to be undefined. Right, so why am I saying that? You're going to see now you got minus cot x there. When you're substituting, it's going to be minus 1 over 10. X minus x is equal to 1 over 4, 1 plus t squared all squared. Okay, so the main thing is you understand all the integration up to this stage here, how we separated. Now it's just, there's just an error here in the example that's given to us, because when we substitute x is equal to 0 here, I'm going to have minus 1 over tan 0 minus 0 is equal to 1 over 4. 1 plus t squared, so that's 1 squared all squared. Now the right hand side is fine. The problem is here. So this is going to be minus 1 over tan of 0. What is tan of 0? It is 0. So 1 over 0, you cannot divide by 0. This is undefined. Okay. So unless we're talking about limits as x approaches 0, right? Then your tan graph, it depends now whether you're coming from the right hand side or the left hand side, right? But clearly we are not approaching a 0 here. This is exactly 0. So 1 divided by 0, when we are dealing with limits, it's going to be infinity. But this is not limits now. So therefore, the error here was this has to be swapped around. Okay, in order for it to work out. But at the moment this is undefined, so I'm just going to leave it as it is there. Right, so we will just stop at the general solution here. That's it. Let's move on to the next example. Right, let's separate these variables. So what I'm going to do first is cross multiply. So there's my numerator here, there's a denominator. I'm just going to treat this as 1, x squared dx, so I can cross multiply it one time. Right, so now that's going to be 2y times dy, just times dy. And I'm cross multiplying here, so that's going to be multiplied by the square root of x cubed plus 1. So there's it there, and now this way. So that's going to be 1 times everything here, which is x squared dx. So I got rid of those fractions. Can you see that? Right, so I got rid of the fraction. Now, I got my dy here. Well, the 2y is there, that's fine. The problem is this, I need to divide it, and that's all. Because there's no other terms here with the y, so all I need to do is just divide. So now I got my 2y dy is equal to x squared all divided by the square root of x cubed plus 1 dx. Alright, now let's have a look at our integration. Left hand side, simple. All you're going to do is y squared over 2. Okay, that is sorted out. Right. The right hand side is what you need to focus on. So my right hand side here is a fraction. It is a fraction. Just like the, where's the one that we had, which is a fraction? In the previous one, we don't have it here. Let's see here. But the question is the numerator a derivative of the denominator? Okay, the answer is no straight. Why? Because the denominator, don't forget that there's a square root here. Right, that's a common mistake. You're forgetting that if there was no square root, then we could say, yes, the derivative of x cubed is going to be 3x squared. Right, but the derivative of the denominator will have to be the chain rule. You understand? That is going to be half x cubed plus 1 to the power. There's no half x to the power. You can see that on the top. So therefore, this is not the division type. It is, what we need to do is we need to take this to the top. And it is exactly this type here. Multiplication. F of x to the power n multiplied by f prime x. That's exactly what we need to do. So what do I mean? I got my x squared all over x cubed plus 1 to the power half. But now I need to take this to the top. So therefore I have x cubed plus 1 to the power minus half times x squared. So you rearrange it. Now clearly what's on the inside is your function of x there, and what's on the outside is your f prime. Not 100%, or you know what we're going to do here. It's just a simple inspection trick here. So this is ready. Then I got my 2y dy. So let's integrate both sides. What did I forget? I forgot to write down my dx. That's dx. Alright, so you must recognize. That's why you have to do hundreds of examples in order for you to recognize something in 2 seconds. You just know, okay, this is the division type, that's multiplication. Okay, so here is the same. These 2 examples are of the same type. It's just that this one has x, this one has t. So now, when you integrate, sorry, not when you integrate, when you differentiate, the derivative of x to the power 3 is going to be 3x squared. So if I write down a 3 there, I'm going to multiply by 1 over 3. So now I got 2y, 1 plus 1 is 2 over 2. Alright, here is going to be 1 over 3, x to the power 3 plus 1, and minus 1 over 2 plus 1 now. So therefore, what am I doing? I'm going n plus 1. So minus 1 over 2 plus 1 or minus will be, basically that's going to be half, all divided by half, plus c. And that is the general solution. Let's work out the particular solution. Let's just substitute our values. Substitute your values. Let's find the value of c. You can simplify. Alright. Alright, so if you want to, you can simplify that. 2 and 2 cancel. So you end up with y squared is equal to 1 over 3 divided by 1 over 2 is the same as 1 over 3 times 2 over 1, which is going to be 2 over 3. Or if you want to leave it like this here, it's fine. It's up to you. Alright, I'm just simplifying it a bit further there. And that becomes the square root of x cubed plus 1 plus c. Right, so what are the values we need to substitute? This is c. Y of 2 is equal to 1. So y of 2 is equal to 1. So what does that mean? When x is equal to 2, y is equal to 1. Let's substitute and see what we get. So that's 1 squared, 2 over 3. That's 2 to the power 3 plus 1 plus c. So that's going to be 2 over 3. 2 to the power 3 is 8. 8 plus 1 is 9. The square root of 9 is 3. Well, lucky I don't have to use a calculator. 3 and 3 cancel. So therefore 1 minus 2, c is equal to minus 1. Anyone got the same answer? So therefore y squared is equal to 2 over 3 times the square root of x cubed plus 1 minus 1. And that is the particular solution. Right, so we deal with the next example. Right, so example D, let's separate these variables. Now, let's see what can we do here. So, we got d theta on the left hand side, dt on the right. Let's leave d theta on the left, dt on the right. Okay. Now, here I got d theta on the left hand side. I got 1 plus theta squared as a denominator on the left, which I'm going to leave there. Okay, so what I want to do is, since I got the t and the dt on the right hand side, I need to get 1 plus t squared also on the same side as dt. So what will I do? Right, so if you cannot do it in once, let me just show you what's going to happen here. So I do not want this 1 plus t squared on the left hand side. So I will multiply by 1 over 1 plus t squared. So 1 plus t squared and 1 plus t squared will cancel. You can see that? Whatever I do on the left hand side, I must do on the right hand side. So that will be 1 all divided by 1 plus t squared. So now my left hand side is just 1 over 1 plus theta squared d theta there. And this is going to be t times 1, which is t all over 1 plus t squared dt. Now it is almost, so you can say almost ready to integrate. Right, so let me put in my integration sign on both sides. Left hand side with respect to theta, right hand side with respect to t. So now on my left hand side I got 1 all divided by 1 squared plus theta squared. Why am I doing this? You should realize by now why am I doing this here. Because there's no theta on there's no exact derivative here. If there's no exact derivative, it's a fraction. This is trigonometric substitution. But we're not going to go and derive it the long way like what I did on the board last time. I'm talking about just go and apply the relevant formula. On the right hand side, I got my t there, 1 plus t squared. And clearly, this is a fraction, but it's not the same type as the left hand side. Here, I got t there, which is a derivative of t squared. So I know I can use inspection or I can use u substitution. So the derivative of t squared will be 2t. So if I put a 2 there, I need to cancel the 2 by multiplying by 1 over 2. Once you understand this, then there's you know, N5 will not be difficult for you. And once you understand the inspection technique. Now, the left hand side, this side here is of the form 1 over a squared plus x squared dx. You go to your formula sheet, this is 1 over a inverse tan x over a plus c. So that is dealing with how to deal with that one. So basically, your constant a is 1, theta here, well x is theta, you can say that. So you apply the relevant formula one time. So this is going to equal to 1 over a, which is 1 over 1, in this case a is 1. Then I got inverse tan x over a, well x is theta, so that's going to be theta over 1 is equal to, that is my left hand side. The right hand side, the numerator is a derivative of the denominator. So you know we've just done that there, so that's going to be half ln absolute value of the denominator plus c, and that is the general solution. You can see the integration is very important here. You have to do hundreds of examples for you to just in 2 seconds identify exactly what to do. Okay, so now what can we do now? What do we need? This is not the final answer. We need to substitute when theta is equal to 0, t is equal to 1. So there's a here. When theta is equal to 0, t is equal to 1. So let's go inverse tan of 0 there, and then I'm going to substitute 1 over 2, then 1 plus 1 squared. You can use your calculator straight. So when theta is equal to 0, t is equal to 1. We work out the value of c. Now since this is just a 0 here, it doesn't really matter whether your calculator is in degrees or in radians, because 0 is 0, you're going to get, sorry, yeah, but because inverse tan of 0 is still 0. And the answer is 0. And here we got just going to be half ln 2 plus c. So basically c is equal to minus 1 over 2 ln 2, which is equal to
0,347.
Positive 0,347. So that is the value of C. And now we go back and substitute. Remember, this here was the general solution. But this is
going to be negative.
negative.
Yes.
Negative, yes. Sorry, I forgot negative. So that is negative. So now we go back here. So therefore, 1 minute, let me just copy this down. Inverse tan of theta is equal to 1 over 2 ln of 1 plus t squared minus 0,347. This is the particular solution. You had a question? Because I took this to the left hand side. That's right. Remember, I got 1 over 2 ln 2 plus c. So I need to isolate c. So that means I must take this to the left. It will become negative. Alright, copy this down. Let's move on. We still got many more examples to do here. Alright, so this one, we got just one term on the left, one term on the right. Right. It's multiplication here, so it's regarded as one term. So we can divide to separate the variables. So let's see. All I have to do is divide by 1 plus y, and then divide by sine squared. I'm going to do it one time. Alright, so that is going to be dy divided by 1 plus y is equal to cos squared x dx, all divided by sine squared. Alright, not too bad, simple one. Now we need to integrate both sides. So you introduce your integration. There's dy, that's dx. My left hand side is 1 over 1 plus y. Right hand side needs to be simplified further. So cos squared divided by sine squared is cot squared x. Now, okay, let's go back to the left hand side. This, we've been doing it so many times now. You should know that the numerator is a derivative of the denominator. It's a fraction, top, f prime on the top, f in the bottom. So this is going to be ln absolute value of 1 plus y. Here, there is nothing that when you differentiate gives you an answer of cot squared. There's nothing on your table of derivatives. So therefore, this is not a standard integral. So we need to use our square identity for cot squared. Okay. We need to use our square identity because cot squared, well, it's not a standard form. So 1 plus cot squared is equal to cosec squared. You should know by now 1 plus cot squared is equal to cosec squared. So cot squared will be written as cosec squared minus 1. So now I got my ln 1 plus y on the left hand side. The right hand side, you know that when you differentiate cot, the answer is negative cosec squared. But since this is a positive, so when the answer will be negative cot minus x plus c. What values are we substituting now? Oh, lucky we're not going to get this one example. It was undefined, but not this one. Right, so now let's substitute our values. So y of pi over 4 is equal to 1. So what does this mean, y of pi over 4? So when you're reading this, what variables are we dealing with? X and y. That means when x is equal to pi over 4, y is equal to 1. Right, so don't go and mix it up now. When x is equal to pi over 4, y is equal to 1. So that's going to be ln 1 plus 1 there is equal to minus, now cot, let's write it as 1 over 10. Because we need to use the calculator. There's no cot on the calculator. So you can write it as 1 over 10 or cos over sine. It's up to you. You're going to get the same answer. So I'm writing it as 1 over 10x What is x here? It's pi over 4 minus pi over 4 plus c. We now must change to radians on the calculator. So remember this one, calculator in radians. So let's see here, I got ln 2 plus 1 over 10 of pi over 4 plus pi over 4 is equal to c. I need to make c the subject of the formula there. You can say that. So take out your calculator in radians and let's work out the answer. Well, I know that this is 1, this is going to be 1 because 180, but I'm just, because I know the graph, but you do it in radians one time, you should get it. Give me the calculator then. So, 1 second, so that's ln 2. Two comma 479. Is that correct? Yes. 2,479. So C is equal to 2,479. What was that? 9, huh? 479. So that is C. Now let's substitute back. Remember, this is, where is my general solution? This was the general solution. So you will take this value and substitute it there. So that's going to be ln 1 plus y is equal to minus cot x minus x plus 2,479. Everyone gets the same answer there?
Yes, sir.
The calculator here. Let's move on to the next one.
Sir,
Yes.
in the second step, sir, what would have happened if we said 1 over 10 squared cot for cot squared x?
The problem is if you write cot squared, okay, your question is cot squared is 1 over 10 squared. Now, the problem is here now it's a fraction, but the numerator is not a derivative of the denominator, you see? If you had 10 squared in the bottom and the exact derivative of 10 squared on the top, which is 2 tan x times the derivative of 10 is sec squared, and if I got 10 squared in the bottom. So his question, this was the question, what happens if it was 1 over 10 squared? You cannot integrate this here, but if it was this question, then the answer is going to be ln of 10 squared plus c, because we have an exact derivative on the top. That's a different situation. So 1 over 10 squared must be written as cot squared, and cot squared must be written as cosec squared minus 1, and then you integrate. Let's move on to the next example. Alright, so we're going to go straight for example G. And so now, here, let's see, we got dy here, and we got dy there. What can we do? Let's take all the dy's on one side. Let's see what happens. Okay. So now we got cos x sin y dy minus cos x cos y dy is equal to your tan x dx here. Okay. Now, if I take out dy and cos x as a common factor there, Yeah, my common factor there is cos x times dy. So that will be cos x dy as a common factor. So I'm left with sin y minus, I said that's cos x dy minus cos y. Correct. Let's double check that. That's minus dy, yeah, is equal to tan x dx. Alright, now I can go and separate. Well, I got my dy on that side, I got these terms on that side. All I have to do is divide by cos. Now you can see that. So divide by cos, so I got dy, and that's sin y minus cos y is equal to tan x dx, all divided by cos x.
So,
Yes.
what if we just took out dy as the common factor?
If you took out dy only as the common factor, then in the next step you would still have to take out cos x. It will be two steps because you can't have cos x sin y and then cos x cos y. We have to separate those variables, you see. That's why we had to remove the cos x also. Because that's the only way now we can get our dy's on one side, dx on the other side. Now, let's integrate both sides. So I'm going to go integrate the left, integrate the right. So that's going to be sin y minus cos y dy. And here, alright, so here for this one, 1 over cos. What is 1 over cos? Sec. So this is going to be sec x tan x. You can't do it in a different way. You can write it as sine of a cos, and then you know you're going to have sine of a cos squared. You're going to take, but well, it will take longer. But the fact is, when you see tan divided by cos, remember 1 over cos is sec. Now it's simple from here. The tricky part was the beginning, to take out the common factor. That was the tricky part. You can see that. Integrate sine, you get minus cos y. Integrate cos, it's just sine. Now you know, what did you differentiate that gave you sec tan? Sec. So that will be sec x plus c. That is your general solution. What are we substituting here? Y of pi is equal to 0. That means when x is equal to pi, y is equal to 0. Alright, so I'm going to go minus cos 0 minus sine 0 is equal to 1 over cos of pi plus c. So I know that cos of 0 is 1, so that's going to be a minus 1. I know that sine of 0 is 0, so that's 0. Cos of 180 is minus 1, so that's a minus 1 also here. Plus c. That means c is equal to 0 here. C is equal to 0. So therefore, you have minus cos y minus sin y is equal to just sec x. And that is the final answer. Because c is 0. You don't have to write down the 0. Alright, we continue next time with second order.